So inverse trig functions and the unit circle can also help us find angle measures that satisfy a given range of values. So for example 3 and 4, you see the same exact question being posed differently. Example 3a and 4a are the same, 3b and 4b are the same, except for the directions are different. So for example 3, they want us to only consider the range of values that are between 0 and 2 pi when we're considering our answers. So that leaves us with one full revolution of the unit circle, as opposed to if you look at example 4, they want you to find all the angles that satisfy a given condition. And we'll come back to what that means on the unit circle. So for example 3a, you have that all values in which sine or y is negative falls in the third quadrant and the fourth quadrant. So there's two angles, one in the third, one in the fourth, in which sine is negative. The reference angle is pi over 4 for rad 2 over 2. So my first angle I'm going to highlight in pink here, and I drew that wrong. It's starting at the positive x-axis to here, so it's 1 pi over 4 past pi, which is 4 pi over 4, so 5 pi over 4. One of my angles is 5 pi over 4. So sine of 5 pi over 4 is negative rad 2 over 2. My second angle would be starting at the positive x-axis, but this time going all the way over to the fourth quadrant, and that is 1 shy of 8 pi over 4, which is 2 pi, so 7 pi over 4. My other answer would be 7 pi over 4. So there's two angles between 0 and 2 pi that satisfies that condition. So these are my solutions to a question when they're asking for a given range of values. For B, tangent of theta is equal to 1. We know tangent of theta is equal to 1 gives us a reference angle of pi over 4 as well. So the reference angle is pi over 4. Which quadrants give us positive 1 as an answer for tangent? That would be an angle in quadrant 1, as well as all students take calculus, take being here. So all students, that means that tangent is positive in the third quadrant as well. So my first angle measure in pink is in the first quadrant. So one of my answers for theta is pi over 4. My second angle, which I'll do in blue, is in my third quadrant. Pi over 4 is the reference angle, 1 pi over 4 away from 4 pi over 4, so the other angle measure is 5 pi over 4. Now when we move on to example 4, we're asked the same exact question, but this time they want us to find all the angle measures that satisfy the condition. So if we take away that 0 to 2 pi restriction, we know that there's multiple answers because we can do multiple revolutions about the unit circle. So to give you guys a basic understanding, if I find sine of 0 is equal to 0, and I do one full revolution and I add 2 pi to that, I get that sine of, sine of 0 is 0, sine of 2 pi is also 0. If I do another revolution, I land back at the same spot where y is still 0. So sine of 4 pi is also 0. So we can continue adding 2 pi and doing multiple revolutions and yield that and the answer is that there is an infinite number of solutions for that. So how do we express that? So we know that the first revolution that gave us a negative rad 2 over 2 was, and let's highlight that here, the answer was 5 pi over 4. And then my next answer was 7 pi over 4. Because they are in the third and fourth quadrant, the next time I would get to 5 pi over 4 again, in that same spot, I would have to add 2 pi to that. So one way of doing this, and it's going to look a lot like when we were doing domain and vertical asymptotes for tangent functions and cotangent functions. So theta equals 5 pi over 4, and all other angles that fall, so all other coterminal angles that fall on that same angle. So we say that it's true for all plus 2 pi times some constant you can call k, or sometimes textbooks call it n, 2 pi n, okay, where n is any integer. So the next angle measure would be 7 pi over 4. Same thing is true. If I continue to add an infinite number of 2 pi's to it, I would land back with the same terminal side. same coterminal angle. So those values all give me negative rad 2 over 2. This is how you would find a general solution. So tangent is interesting. If you guys take a look at the tangent that we drew above there, the question is, what would you add to get from the pink angle of pi over 4 to 5 pi over 4? So pi over 4 plus 4 pi over 4, or pi, would get us back to 5 pi over 4. And then if we added another pi, it would give us another 180 revolution back to where pi over 4 is the reference angle. So to encapsulate the answer to B, we would say pi over 4, but we don't have to add 2 pi. We could say that we can just have one expression that adds pi n number of times, where n is your number of integers.